Right, so what is the chain rule? I like to think of it as the interior exterior rule, or some sort of inside outside. Um, Before you buy a house, you always look on the outside, right? You want to see what are the damages, etc., before you take a look on the inside, right? So this is all that says. You take the derivative of the outside and you multiply that by taking the derivative of the inside. So rules as stated. Let's do some practice and to see what we're really doing right here. All right. So I'm going to write my y prime. All right. Well, the derivative of the outside, well, derivative rules hasn't changed and will never change, right? So I'm going to bring down my 24 in front, do 1 minus that, right? So this will be 24 times 3x minus 1 to the 23rd power, all right? And then all I'm going to do is multiply now by the derivative of the inside, right? So multiply by the derivative of the inside. Derivative of the inside is just 3. Because the derivative of x is 1, and then the derivative of negative 1 is just 0. That's a constant, right? So our final answer will be y prime is equal to, well, you always want to multiply your constant in front, right? So I'm going to put this in front here because this is actually being multiplied by the whole thing, right? And it being behind here just looks a little bit weird. Right? So I'm going to put my 3 in front and multiply by that 24. Right? So 3 times 24 is what? 81. No, 3 times 24 is 72. Oh, I'm tripping. Right? 3 times 24 is 72. 3x minus 1 to the 23rd power. And this will be my answer. Right? Let's look at another one. How about this one? Right? So y prime, nothing changes. I'm going to bring my 7 down, do 1 minus that, and then multiply by the derivative of the inside. That's what the chain rule says. So this will be 7 multiplied by x squared plus 4 over x minus 2 to the 6th power. Yes? Now I'm going to multiply this whole thing by the derivative of the inside. Now, the derivative of the inside, we got to use the quotient rule right here. So the quotient rule says, right, the quotient rule says derivative of u, which will be 2x, times plain old v, which is x minus 2, minus plain old u, which is x squared plus 4, multiplied by the derivative of v, which is just 1, right? All over x minus 2 squared, right? We're going to square that, right? So we're here so far. Yes. So we could do a little bit of simplifying. So again, my y prime will be 7 multiplied by x squared plus 4 over x minus 2 raised to the 6th power multiplied by, well, 2 times x. 2x times x is just 2x squared, right? Minus 4x, right? Right. Anything times 1 it's itself, so I could just go ahead and distribute. So this will be a minus x squared, right? Minus 4. And this will be all over x minus 2 squared, right? So doing some simplifying here, my y prime is going to be 7 over x squared plus 4 over x minus 2, right, to the 6th, right? Multiplied by, well, 2x minus x squared is just x squared, right? Minus 4x minus 4 all over x minus 2 squared. All right. So in a perfect world, this would be my answer. However, I could simplify a little bit, right? So the rules for, adding and subtracting, right? Whenever you have the same base, right? Because I see that I have, x minus 2 and x minus 2 here, right? So I'm going to add my exponents. So this x minus 2 is raised to the 6th power. So, I could rewrite everything in one by raising this to the sixth power. And obviously this is to the second power. So I'm going to put x minus 2, multiply them, and add my base. Right? So in other words, this will be 7 times x squared plus 4. Right? Plus 4 to the sixth power multiplied by x squared minus 4x minus 4. Right? And this will be all over x minus 2 to the 8th power. Because again, on the bottom, this is being raised to the 6th power. This over here is being raised to the square, right? So the rule says that if you have the same base, you add the exponents, right? E to the x plus e to the x multiplied by e to the x is e to the 2x, right? Because you have the exponents. So nothing here is different, right? X minus 2 to the 6th multiplied by x minus 2 to the second power will give me x minus 2 to the 8th. We just add the exponents, right? Let's look at this one. Here's the thing with radicals. I always rewrite my stuff so I could see my powers. So I'm going to put this as y is equal to 3x minus 5 raised to the 1/2 power. You always want to do that. It's going to makes your derivative much more easier, because anything raised to a power, anything raised to any square root, any square root is just that to the 1/2 power. So always remember to rewrite your radicals like that. So my y prime now, will be, well, all I do is just take my 1/2, bring it down, right? Write my 3x minus 5, right? And this will now be raised to the negative 1/2 power, right? It's going to be raised to the negative 1/2 power because we do 1 minus that, right? And then we just multiply by the derivative of the inside. So the derivative of the inside is just 3, right? Derivative of 5 is 0. Derivative of 3x is just 3, right? And then in an ideal world, that would be my answer, except I could simplify a little bit more. So, you could write your answers with negative exponents. I prefer my answers with positive exponents. So what I'm going to do, I'm going to bring my 3 in, multiply by the 1, right? So I'm going to bring my 3 and multiply by the 1. So on the top, I will have a 3 over 2, right? On the top, I'll have a 3 divided by 2 times the square root of 3x minus 5. All right, times the square root of 3x minus 5, right? And this right here is the same thing as this. All I did was multiplied my 3 by my 1/2, which will give me 3/2. But this whole thing is raised to the negative exponent. So I bring this whole thing in the denominator, which is just the square root, right? I bring this whole thing in the denominator, and obviously my 3 will remain on top because it's being multiplied by that 1. All right, so this will be my answer. Let's look at the last one. How about this one? Again, I'm going to rewrite my problem. All right, this will be raised to the 1/2 power. So again, the chain rule says y prime, I bring down my 1/2 times 7x cubed minus 5x squared to the negative 1/2, right? And now I'm going to multiply by the derivative of the inside, right? So the derivative of the inside, well, 3 times 7 is 21 x squared, because you minus 1 from that, right? Minus 2 times 5 is 10, right? X. And so this will be my answer. Now, you could simplify it a little bit more. Well, not really simplify, but rewrite it, right? So this will be a perfect answer, but I'm going to rewrite mine. So this is what I do. Again, this is being multiplied by this 1/2 here, all right? This is being raised to the negative exponent, so I could put this whole thing down in the denominator to make it positive, right? So this is 7x cubed minus 5x squared to the positive 1/2. Yes, that will be positive. There's going to be a 2 in the denominator because this 2 is being multiplied in the denominator, right? And this, I could just put this in the numerator since it's being multiplied by this 1 in the numerator right here. Right, so my answer will be 21x squared minus 10x. right? This will be my answer, right? Or you could even rewrite the bottom like this, right? You could say, well, 21 x squared minus 10x, right? All raised over 2 times the square root of 7x cubed minus 5x squared, right? This is the same thing as this, right? So these will be your answer. Yes. Right. And that's all the chain rule says. Take the derivative of the outside and multiply by the derivative of the inside.